All right. Today, we're diving into something really different. It's a proposal for building AGI that, well, it's not about just throwing more data and compute at the problem. We're talking about a highly structured linguistic blueprint for creating meaning, and it comes from the work of an independent researcher, Saif Al-Mathuti. This is going to be a fascinating one.
So here's how we're going to break it down. First, we've got to understand the core method behind all this. Then, we'll see how it was put to the test on a huge problem in computer science, P versus NP. After that, we get to the main event, the AGI blueprint itself. We'll peek inside the engine and then wrap up by looking at its promise. And, of course, the big open questions that remain. Okay, first things first. To really get a handle on this AGI idea, we have to start with the tool the author, Mathuti, created to even begin thinking about it. It's called Applied Terminological Deconstruction. And trust me, this is the bedrock for everything else we're going to talk about. So what is this thing really? Well, its whole purpose is to fight back against what the author calls terminological confusion. You know, the idea that a lot of really tough problems are so hard to solve because the words we use to describe them are just fuzzy, imprecise. This method is all about locking things down. It forces you to make sure the word, the idea in your head, and the actual thing out there in the world are all perfectly lined up. And here's the logic in a nutshell. You've got these three layers, right? The symbol, that's the word itself. The concept, the idea it triggers in your mind. And the referent, the actual thing in reality. The whole argument is that stable, reliable meaning only happens when those three are snapped together, totally coherent. The second they start to drift apart, your whole intellectual foundation gets shaky. It's all about that disciplined alignment. All right, so you might be thinking, that sounds cool, but does it actually work? Does this method have any real teeth? Well, to show that it does, Mathuti took it and aimed it at one of the biggest, baddest problems in all of computer science, P versus NP. And just so you know, this isn't some random tangent. This is the crucial stress test that shows what this way of thinking can do. So, you know, P versus NP basically asks a simple-sounding question. If you can check an answer to a problem really quickly, does that mean you can find the answer really quickly too? And Mathuti's approach was to use his deconstruction method on a key term here, time. He argues that the whole confusion around P versus NP comes from mixing up two totally different ideas of time. You've got the abstract symbolic time of a Turing machine, just a series of steps. But then you have physical time, in the real world, which is constrained by stuff like causality, energy, and entropy. So the problem gets reframed. It's not just a pure math puzzle anymore. It becomes what he calls a boundary phenomenon. It exists right at the edge where abstract math bumps up against physical reality. Now look, this doesn't solve P versus NP, but by just cleaning up the language, it completely changes how you look at the problem. And that's the whole point. It proves the method can uncover brand new ways of thinking about really, really tough questions. Okay, and that brings us to the main event. Now that we've seen this rigorous method in action, we can see how the author applied it to AGI. He pivots from pure computational theory to something he calls semantic engineering. This is it, the blueprint for an AGI that's built on a foundation of formal structure, not just on mountains of statistical data. And here it is, the core idea, straight from the paper. Arabic morphology constitutes a rare, well-developed natural system in which form-meaning relationships are explicitly regulated. The big idea here is to look at the highly structured, incredibly regular system of how words are built in Arabic, and use it not as a piece of culture, but as an empirical model. It's like finding a working example in nature of how a system could systematically generate meaning. Now, it's absolutely crucial to be clear on this point. The goal here is not to say that one language is better than another. This isn't about linguistic nationalism at all. The reason for focusing on Arabic is because its structure offers a fantastic model for the computational properties he's interested in, things like generativity and compositionality. The goal is to use it as a blueprint for a semantic engine that is fundamentally non-statistical and rule-based. And that, as you know, is a completely different path from the one today's giant language models are on. All right, so let's pop the hood and look at the engine itself. How would this thing actually work? What's the architecture? Well, the paper lays out a three-layer system that's designed to construct meaning from the ground up, and this is key, to do it in a way that's totally transparent and deterministic. So the core mechanic is actually pretty elegant. At the heart of it, you have this idea of a semantic root. Think of it as an abstract concept, which gets combined with a morphological pattern. And this pattern acts almost like a function or an operator in programming. So for example, you can take the root that means something like emergence, apply the pattern that means to seek or cause an action, and boom, you get the word to extract. It's a system that's both predictable and compositional.
And this is how that logic gets turned into an actual system architecture. You have three main parts. First, a database of all those core semantic roots. Second, a layer of those morphological templates, which basically act like pure functions that transform meaning. And third, you have a structural parser, an engine that can take any word, break it down into its root and pattern, and then logically figure out what it means. And the whole point is that this is not a black box. You can actually trace the steps it took to reach a conclusion.
Okay, and this is where you really see the potential power of an approach like this. We're talking about true zero-shot inference. Let's say the system comes across a word it has never ever seen before, something like mustaz zuria. It doesn't need to make a statistical guess based on context. Instead, it can actually parse the word, identify the root for growth, and recognize the pattern for an agent who seeks something, and from that, it can logically deduce the meaning is something like an entity that seeks or performs cultivation. It's inference from first principles. So, where does this all leave us? What's the big promise of a blueprint like this? And honestly, this is where the paper gets really compelling, because it's just as much about what it doesn't claim as what it does. It balances the really exciting potential with a very clear, very humble acknowledgement of the project's limits.
And for anyone deep in this field, this might be the most important slide. The author is very explicit about what this work is not. It is not a claim to have solved AGI. It is not a claim that Arabic is somehow superior or unique. It does not promise to eliminate hallucinations, and it's not trying to say it's better than neural nets across the board. What it is a research proposal, a blueprint for exploring a fundamentally different way of building a semantic engine.
Okay, so if you go down this road, what's the potential upside? What are the advantages? Well, there are a few big ones, and they hit on some of the major pain points we have with current AI. First, you get real, genuine explainability. You can trace every single inference back to its roots. Second, you get that powerful, rule-based, zero-shot learning we talked about. It's based on structure, not just statistical correlation. And finally, you get a system where meaning is constrained by rules, making it less arbitrary and, hopefully, less prone to making stuff up. And all of this really boils down to the single biggest question at the heart of AI research right now. Can meaning truly be engineered from formal structure, from rules and logic? Or is it something else entirely, an emergent property that you can only get through massive, massive scale? This blueprint makes a bold case for structure. The dominant approach is betting everything on scale. And whether an engineered system like this can ever truly grapple with the sheer messiness of the real world, well, that's the huge open question this work leaves us with. And it's one we're all going to have to think about.